Alright, let's look at the homework 17, problem number 8. Alright, so let's evaluate this double integral using divergence theorem. Alright, so in order to do this, we need to add one more surface because let's see, this is a surface, so you have a paraboloid and it's over the xy plane. So we're looking at the surface here. So this is a surface, you know, it's like top of the egg or something like that. So you have this guy. Alright, and I'm going to add the bottom. So here's the base. Base is just you know, circular shaped base on the xy plane. Right, and so I'm going to call the bottom one, I guess I'm going to call it the base B. So here's a B, right? So if you have a double integral over the surface, right, of f dot with normal, outer normal vector, and then I'm gonna add on the base. So actually, maybe I'm gonna write it this. Let's see. Yeah, I'm gonna do that, and the base B. And the same thing, right? And outer normal vector in this case on B base, it's so outer normal vector would be negative k, right? So this would be negative k. All right. So by using the divergence theorem, we can turn it into a triple integral, right? Triple integral over the solid, so over the solid, so I'm gonna call this guy tau right here. So over the solid tau, it's like a bullet shape. All right, then so it's going to be a divergence. So divergence of f, which is given to be x comma y comma 0, and d tau, right? It's just a volume element. All right, so if you compute that, you can see that divergence is partial of the first component, which is x, with respect to x, it's going to be 1, plus partial of the second component with respect to y is going to be 1, and partial of 0 is 0, so it's just going to be 2 d tau. All right. So this is going to be twice as big as the volume of this guy. So this is going to be 2 times the volume of tau. Alright? Alright, so which can be found by, let's see, 2 times. Alright, volumes, we just have to do a double integral. Alright, so I think it's let's see, polar coordinate would be nice. Alright, so z would be 4 minus. Alright, so you can see that here, this can be rewritten as, because x squared plus y squared would be r squared, so this is same thing as 4 minus r squared. Alright, so 4 minus r squared. Alright, and then r dr d theta, and r goes from 0 to so let's see, so for fixed theta, r goes from 0 to 2, right? So 0 to 2, because radius is 2 there. Alright, theta is going to go from, so you have to go all the way around, so it's going to be 0 to 2 pi. Right? So you compute that, you can get the answer, so I'll let you guys do that. So I did that. So, alright, then what you're looking for is this guy right here. Right? But here, if you compute this guy right here, f is x comma y comma 0. If you take the dot product with 0 comma 0 comma negative 1, it's going to be 0. So this guy is actually 0. So you can actually cancel that out. Alright, so what you get here is actually exactly the same value that you're looking for. Right, so what we have to do is evaluate the volume of this bullet solid and multiply by 2. Right, that's it. I hope that this was clear.